Okay, let's dive right into this explainer. Today, we're exploring a set of ideas that are absolutely going to shift the way you look at the world, the news, and, well, the future in general. We're basing this whole explainer on a legendary presentation by the late Dr. Al Bartlett, an emeritus professor of physics at the University of Colorado. And get this, Dr. Bartlett was so incredibly passionate about this topic that he gave his lecture, Arithmetic, Population, and Energy, over 1,700 times across 36 years. And the best part? It's entirely grounded in simple arithmetic. We're not talking advanced calculus or political spin here, just pure, undeniable math.
Think about the sheer weight of that statement for a second. Dr. Bartlett believed that our absolute greatest shortcoming as a species isn't greed or a lack of resources, but a total blind spot in our basic mathematical comprehension, specifically our inability to understand the exponential function. Now, I know it sounds like high school math, but this invisible force is quietly dictating the limits of our planet, our economy, and honestly, our survival. Let's find out why this is so urgent.
Section 1. The magic number 70. Understanding doubling time.
So we hear about percentage growth all the time, right? The news tells us about a 5% growth in energy demand or a 7% growth in the economy, and that sounds pretty modest. But to really grasp what steady growth means over time, you have to understand doubling time. And for that, Dr. Bartlett gives us this brilliant little mental parlor trick. Just remember the number 70. To find out how long it takes for any growing quantity to double in size, you literally just divide 70 by the percentage growth rate. That's the whole trick. It's called the rule of 70. So if your town's population is growing at 5% a year, divide 5 into 70 and you get 14, meaning your town is going to completely double in size in just 14 years.
We can actually see exactly how this rule of 70 works in our daily lives through the historical cost of an all-day ski lift ticket at Vail in Colorado. So since it opened in 1963, the ticket price grew at about 7% a year. If we apply our rule, 70 divided by 7, that means the price doubles every 10 years. In 1963, it was $5. 10 years later, $10, then $20, $40, $80, all the way to $160 in 2013. This is exactly what a 7% growth rate looks like in reality, even though 7% initially sounds like such a small, harmless number.
Section 2. The chessboard and the bacteria. Visualizing the invisible.
We've seen how this applies to money. Now let's take this mental tool and apply it to physical space and resources, because this is where exponential growth goes from just surprising to absolutely mind-bending. There's this famous legend about the inventor of chess, who asked the king for a seemingly tiny reward. Just place 1 grain of wheat on the first square of a chessboard, 2 on the second, 4 on the third, and keep doubling it for all 64 squares. The king agreed, thinking, it's a super cheap prize. But by the time you reach the 64th square, the total amount of wheat on the board equals roughly 400 times the entire 1990 worldwide harvest of wheat. It is literally more wheat than humans have harvested in the entire history of the Earth, from 1 single grain, doubled just 63 times.
Here is the absolute kicker, the crucial mathematical rule you need to remember. The growth in any single doubling time is greater than the total of all preceding growth combined. Really think about that for a second. When you put 32 grains of wheat on a square, that 32 is larger than the total of the 31 grains already sitting on all the previous squares combined. Every single time a quantity doubles, it consumes more than everything that was used in its entire history prior to that exact moment.
Let's ground this in Dr. Bartlett's famous thought experiment, bacteria in a bottle. Imagine bacteria that double in number every single minute. At 11 a.m., you place 1 single bacterium in an empty bottle. It grows steadily, and exactly at 12 p.m., noon, the bottle is completely full. It's a finite environment, experiencing steady exponential growth. So, at what time was the bottle half full? Just 1 minute before noon, at 11:59 a.m.
Now consider the state of the bottle at exactly 11:55 a.m., just 5 short minutes before disaster. The bottle is only 3% full. There is 97% open, empty space. If you were an average bacterium inside that bottle at 5 minutes to noon, looking around at all that wide-open real estate, would you realize that you were about to completely run out of space? No way! Everything looks totally fine.
But wait, let's say the bacteria launch a massive exploration effort, and at 11:58 a.m., they miraculously discover 3 brand new, completely empty bottles. They have just quadrupled their known resources. The population cheers. Crisis averted, right? Well, let's look at the math. At 12 p.m., bottle 1 is full. Because they double every minute, at 12:01 p.m., 2 bottles are full. And at 12:02 p.m., all 4 bottles are completely full. Quadrupling their resources bought them exactly 2 extra minutes of survival.
Section 3. The fossil fuel illusion, fact versus fiction.
Let's pull these mathematical concepts out of the bottle and apply them to the real world. We aren't bacteria, and our bottles are the Earth's non-renewable resources, like fossil fuels. When you hear experts talk about our energy reserves, the math often gets completely ignored in favor of comforting rhetoric. You've probably seen statements like this one, based on a report to the U.S. Senate. It's incredibly reassuring, isn't it? We have enough coal for over 500 years, at current levels of output. It makes it sound like we don't need to worry about energy for centuries. But Dr. Bartlett points out a massive catch hidden right there in plain sight.
The catch is those 3 little words, at current levels. That phrasing mathematically means a state of absolutely zero growth in consumption. That optimistic 500-year projection is 100% reliant on the assumption that humanity will never, ever increase its coal usage again. But wait, pretty much every segment of modern society demands continuous economic growth. You literally can't have both.
Watch what happens when we apply actual historical growth rates to those exact same coal reserves. If we plug in the historic 2.86% growth rate, that massive 500-year supply suddenly vanishes in just 72 to 94 years. And back in the 1970s, when the national goal was 8% growth in coal production, that would have wiped out the entire 500-year supply in less than 46 years. The math is completely ruthless. You simply cannot have exponential growth of consumption and expect a finite resource to last.
Section 4. The Sustainability Paradox, Nature's Choice.
This brings us to a highly sensitive but mathematically unavoidable topic, the human population itself. Dr. Bartlett framed this strictly through the impartial lens of arithmetic, presenting us with what we can call the sustainability paradox. He lays out a pretty chilling dilemma. On one hand, we have medicine, public health, peace, clean air, scientific agriculture. These are all humane, universally positive things that lower the death rate. But mathematically, everything that lowers the death rate increases population growth, which accelerates the depletion of our finite bottle. On the other hand, things like disease, war, and famine raise the death rate and mathematically reduce the population problem. But obviously, we universally agree these are horrific.
So, the crucial takeaway here is this. Zero population growth is a mathematical certainty on a finite planet. Endless growth in a closed system is just impossible. We can debate whether we like zero population growth or not, but the math says it is going to happen. If humanity doesn't voluntarily choose ways to stabilize the population, nature will inevitably step in and balance the equation by choosing from the horrific list we just discussed.
Section 5. The first law of sustainability, the final equation.
Everything we've discussed today, the doubling times, the bacteria in the bottle, the real lifespan of coal, it all converges into one definitive takeaway. We throw the word sustainability around a lot today, but without math, it's just a corporate buzzword. Dr. Bartlett's first law of sustainability states simply, population growth and/or growth in the rates of consumption of resources cannot be sustained. This is not a political opinion. It's not an ideological stance. It is an undeniable structural fact of basic arithmetic. We live on a finite Earth, and you absolutely cannot sustain infinite expansion on a finite sphere.
I want to leave you with this final, memorable challenge from Dr. Bartlett. Look at the immense challenges we face today, from water shortages to climate change to poverty. Can you think of any problem, on any scale, whose long-term solution is actually aided by continuous, exponential growth in population or consumption? Does cramming more demand into our finite bottle actually solve anything? Think about it. Thanks for joining me on this explainer, and remember to always respect the arithmetic.